All right, the next topic that we're gonna hit is domain and range. Okay, there's two kinds of domain and range. First is mathematical domain and range. All that means is there's no situation that limits the domain and range. Okay, so if they are asking for the mathematical domain and range, okay, for any linear equation or linear function, it's usually the domain is going to be all real. The range is going to be all real. For quadratics, the domain is all real. Okay, the range is going to be y is either greater or less than or equal to the y value of the vertex. Okay, for exponential, okay, the reason for this, okay, let's look at linear. Okay, you see linear looks like this. It goes all the way to the left, it goes all the way to the right, it goes all the way down, and it goes all the way up. That's why it's all real. For quadratics, remember, it keeps on going to the left, it keeps on going to the right. That's why it's all real. You see, the vertex is the bottom point or the top point. Okay, that's why it's either going up or it's going down. It's going up, it's greater than. It's going down, it's going to be less than. For exponential, remember our graph looks something like this or like this. Okay, so the domain here is going to be all real also. The range is going to be y is greater than or less than the asymptote. Remember, the asymptote is that horizontal line, okay, where the line looks like it's going horizontal. Okay, that's where you can find the asymptote. Okay, that's if they ask for mathematical domain and range. That means no restriction. Now, domain and range in a situation, things you need to consider: the type of numbers, is it real or integers? Where it starts, is it possible to have a negative number? If they give you a domain as numbers, if they give you the domain as numbers, substitute to find the range. Okay, we'll do some example problems and you might be able to see what I'm talking about, okay? So, alright, let's look at our first problem, okay? It says, which graph shows a function with a domain? Okay, we want a domain with all reals greater than 7. So domain, we're looking at our x, right? So if you look at this one, this is 7. Okay, I always like to draw a straight line, okay? This one right here is also 7, okay? This one right here is 0, so that's not correct. This one right here is 7, okay? But remember, we want it greater than 7. That means we want, when we draw that line, we want everything over this way, okay? See, there's nothing over here, okay? There's nothing over here, so this is wrong. There's nothing over here, that's why this is wrong. You see this line is going this way, so this is greater than 7. Remember, domain is our x. There's our x value, okay? All our x value. So A is the best answer here. Okay. It's a function f is graphed below. What is the range? If I look right here at range, remember, we go from the lowest to the highest, the bottom to the top. So I draw it to where the y is. Okay, so this is where the y is. So, and then it goes to here, positive 3. Okay, now I look at my dots. See, this one is greater or equal because it has a closed. This one is open. Okay. So remember, our range is our y value, so this is incorrect right there. Is -3. We use the closed to open. Alright, why don't you try this one on your own? Okay. The graph of the exponential function is shown on the grid. Based on the graph, which statement about the function is true? The range is all of the sets of real number less than 0. You see, this is where our range is, okay, here and up, okay, so it should be greater than 0, so this is wrong. The domain is a set of all real numbers greater than 4. Remember, our exponential function, our domain is always all real, not greater than 4, guys, because it's just all real. Remember, this one, as long as it goes, it keeps on going, okay? The range is a set of all real numbers greater than 0. This looks good. See, this is 0 and it's greater than 0. Okay, again, the domain, remember, it's supposed to be all real, so that one's incorrect. Why don't you try this one on your own? Okay, what is the domain of f of x is equal to 9 minus x squared? So, you see there's no graph, there's no stories or anything. This is a mathematical domain and range, okay? So if you graph it, it looks like this, okay? And our x keeps on going to the left, and it always keeps on going to the right. Okay, so here our mathematical domain and range is going to be all real. Okay, you just have to remember that the mathematical domain is always all real for all of them. Okay, what is the range? Remember, range is like our y, or in this case, it's going to be our f of x. So it's going to be these numbers here, -9, -4, -1. Why don't you try this one on your own? And this one. Okay, now we have a problem. The number of ferry boats needed to transport sea cars, the number of ferry boats, okay. So this is ferry boats, since they have f of c, okay, needed to transport c cars in one day. C is cars, okay, that's kind of like our x. If there are no more than 5,000 cars transported by ferry boat, what is the range? Okay, so my maximum number is, okay, what is the range? So no more than 5,000. So my maximum is 5,000, okay? So I'm going to put 5,000 into this problem. So 5,000 over 20 gives me 250. So my maximum number is 250. So it's going to be, instead of all integers greater, it's going to be less than, okay? Okay, it's all from 0 to 5,000, because we can't have less than 0. There's no such thing as negative cars. Okay, so set of all integers from 0 to 250, because we're looking for the range, okay? So that's why I had to substitute. Okay, the table shows order pairs that belongs to a quadratic function. Okay, it just shows some numbers, okay, and doesn't show all numbers. So if you look at this, you're looking, see, the graph is going down, 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 down. So it stops here, then it goes up. So the graph goes here, down all the way to -8, then it goes back up. Okay, so it should be all real numbers greater than or equal to -8. Again, we were looking for the range. That's why we looked at the bottom number. Okay, so the total cost in dollars to buy uniforms for the players on a volleyball team can be found using the function C is equal to, so U is the number of uniforms. Okay, if there are at least 8 players, so 8 players, right? So I start at 8, but not more than 12, so, and I go to 12 on the, what is the domain? Okay, the domain is your U, okay, you see that? That's going to be your uniform. Okay, the number of players is going to be the same as the number of uniforms, so it's going to be 8 to 12, 8, 9, 10, 11, 12. The total cost of renting a banquet hall is a function of the number of hours the hall is rented. The owner of the banquet hall charges $85 per half hour, up to a maximum of $4, 4 hours plus a $50. Okay, so 4 hours. Okay, 85 for every half hour. Okay, plus a $50 cleaning fee. What is the greatest value in the range of this situation? So it's $85 for half an hour, so that's times 2, so that's $170. Okay, times 4, this is $170 for each hour. So 680 plus 50, so that should be 730. Okay. Alright, why don't you try this one on your own. This one. This one. This one. This one.